All right, here's my Milestone 2 video. My name is Noah Bates. My progress so far is I've done the Milestone 2 analysis. Concern is my sampling frequency. Um, for number 8, it said in the lab to do 0.2 for every 20 seconds and 25 minutes. I did 20 minutes at taking samples every 10 seconds. Um, I couldn't get 20 seconds to work for some reason. My microcontroller wouldn't do it. So I just stuck with 10, which is in the video, but I ended up getting good results, so I think that's okay. Here's my experimental setup. I've got my insulated mug here. It's a little small. I'm not sure if it's as big as we wanted, but it held 34 degrees pretty well. It was so insulated that the ice I put in here one night, I left it out overnight, and when I woke up in the morning, there was still ice in the mug. Um, here's my setup. Here's my ice bath. Here's my microcontroller with thermocouple and my laptop, of course. First thing is number 8. I believe that's number 8. I apologize. Time values attempted were 3, 2, and 1 seconds. 1 second appeared to be the best. I tried to go under 1, but the microcontroller didn't want to do that. It didn't want to read. When I put in 0.6 or something, it didn't want to go less than 1 second. But 1 second worked out pretty well either way. And we'll go over that graph. The time frequency and values. I did time values of 5, 3, 1, and 2 seconds with the respective frequencies of 10, 5, 10, and 15. And we'll go over those graphs as well. Here's a step from number 7. We have coming out of the ice bath at 250, that's sharp incline. Then we have it slowly moves around, goes up back to our room temperature value of around 270 here. That's around 18, 19 minutes. So the fact that I made it 20 minutes didn't really matter. Here's the mock data for number 9. We're sitting at around 270, which is room temperature, just to see how well the thermocouple will react. A little squirrely, but we're only going up to 271 and down to 269. So the graph really isn't that bad as it seems. 2 seconds versus 1 second. Like I said, I chose 1 second just because at the very end here, we have a nice smooth line. 2 seconds, we have that nice smooth line, but there's just a lot of extra data here that's not needed because the 1 second, we get it right at the end. Right before 1 second, we can see that it does well. Step 7, again, here's that graph. Here's my room temperature value, the first values. Around 271 was my temperature. Here's all that data. Step 8, again, here's all my data. I tried 3, 2, and 1 seconds. I didn't even try and plot the 3 seconds just because the 1 and 2, it was obvious the 1 was going to be better than 2, and 3 was obviously going to be worse than 2. And 1 was the best, again, just because of that little bit of good data right before we get that 1 second. And then step 9, again, here's the times and frequencies I tried. 2 and 15 I thought was the best. 1 I thought was just too little time. We get barely any data here. 3 was nice, but the frequency was so small, still just barely any data. 5 and 10 was just way too much data, I thought. So 2 and 15 I thought was just a good medium of the good amount of data to get. And again, there's that mock data graph. I think there's some questions. Why should we use a large insulated cup? You got to make sure the thermometer is in the water all the way, or else it's not going to read well. Also, you want something that's insulated well, so it's going to hold that low temperature nicely. You can't just use like a plastic cup. And I think I went over how many minutes it took. I think about 18, 19 minutes just to get back to room temperature. So that's my video. Thank you very much.